I'm Jim Moon, Chief Technical Officer here at Sotera, and a member of the Board of Directors. The company, started by Matt Benet, had developed the technology, the fundamentals, the fundamental science to do the continuous non-invasive blood pressure measurement. And at that point, it became a question of how do you embody this in a product to get it to the market. And that's where I joined forces with Gunnar and Gary and a few other people, pooling our respective perceptions and perspectives of the market from our prior experiences to say, what is the nature of the product that we really want to build this into that's going to have maximum impact. Not just because of impact of the continuous blood pressure, but impact overall for all of its characteristics. One of the things that occurred in that discussion, interestingly enough, it's anecdotal, was when the discussion came around to, you know, boy, if we could just put this on your arm like your watch, those kinds of comments. One of the quick pieces of object that was near at hand was a business card. And at that point, we said, a comment was made, give me the square one as well, mm-hmm. It can't be any bigger than a business card or it's going to be too big. And that's why the actual VisiMobile is the same size as a business card.
Talk to me how difficult it is to design a product like this that works absolutely seamlessly in a hospital.
That's hard. It's hard because it requires a lot of attention to detail. It obviously has to work 24/7, error-free, bug-free. But it also has to have long battery life. So in the embedded side of the world, you count, you know, my term is femtojoules per instruction executed. So every time you execute an instruction on the processor, you consume energy. Okay, so the fewer instructions you can get the job done with, the longer your battery is going to last. That's that linear. Mm-hmm. And so optimizing for power consumption, there are 7 power buses in this device that get turned on and turned off, sometimes for a few hundred microseconds even to save power. Whenever you don't need that particular supply voltage, you shut it down and save power. So it's all of that system level design. It's not just a question of moving data and doing some calculations and putting something on a display. It's managing that whole process in the context of real time. Nothing ever stops. You can't say to the patient, can you hold that next heartbeat? My computations aren't ready for it yet. So everything has to happen in real time, continuous data flow, continuous process of information. And at the same time, be able to know when you can say, okay, I got done ahead of time, I can shut things off now for a millisecond or two and save some power. So it's a whole combination of things. It's also, we designed this system with a division of functionality. So there's multiple processors in this device so that we distribute that computing load over a number of devices and give ourselves flexibility as we go forward and want to add additional functions and features. We can do that in a very flexible, dynamic way that can adjust where those processing burdens are according to the nature of what it is that we choose to add. And by doing that, we've given ourselves a lot of room to grow and room to move. We're not stuck in a box with no place to go.